Hello again, this should be the last chapter for the Radiola 528MA. Just trying to put some cables in the right position. I finished the rewiring and I finished component replacement with it, and I'm pretty happy with it. There is one problem in that the converter valve, which is a 6A8 here, because it's meant to be a shortwave radio, it's not meant to be a 6A8, it's meant to be an X61M. Anyway, it's a matter of finding one of those, but in the meantime it works fine on the AM broadcast band and it works to an extent on shortwave. I'm not going to try and align it fully on shortwave because the 6A8 has got too much capacitance and it doesn't like oscillating properly up the top end of the band, which in this case is up around 18, 17, 16 megs. But it does pick up some stations around 16 megs. So I'll leave that aside for another time in the future. If I get an X61M, I'll do some realigning with that. But in the meantime, you've seen the sweep generator on the IFs, and so they're pretty much aligned. I've just got a normal modulated signal generator at the moment running at 455, and I'm not going to, just peaking up there, so I'm using the frequency that it was aligned on with the sweep generator. Whether it was 454 or 455 or 456 or whatever, doesn't matter so much as that it's all tuned. All the IFs are tuned to that frequency, and I can verify that that's the case by looking at that buzz, by the way, is coming from this fluorescent light. So if I put that off so that you can't see what I'm doing as well, and I look at the IF transformer, as you can see, minus all the noise there because the amplitude is pretty low, that's at its peak. So I'm not going to get any more out of that, and same is true with this one. Just not going to get anywhere more. And the other side of the IFs is the same. So the IF alignment's about as good as it's going to get. I have been experimenting, but it's all very temporary, as you can see. I'll put the light on again. This is a digital sweep generator. It's sitting on top of an ice cream container to try and keep it all together, but it uses a digital ramp to generate the waveform, and therefore it's self-marking, and it sweeps around 455, and it's a very good way to line up IFs in a different manner to a normal linear sweep. Well, linear in that it's a sawtooth sweeping, so it's constant sweep generator. This is a digital one, so I'll try and make it a little bit more permanently so I can use it more easily and show you that one in the future. It was the design was published in a magazine back in 1984. It was designed by a radio amateur operator in Western Australia and published in a magazine that we had at the time called Electronics Australia. So the three pegs, in case you're wondering why I've got three blue pegs there, what they're for, I just turn that tone off. Now, there's a bit of plastic tubing I've got around the outside here, and that's currently gluing, and that's why the pegs are there to keep it there while it's gluing. When this goes back into the box, the chassis, you need something to seal the speaker so that the front of the speaker is sealed from letting the air come around to the back, which is what all the baffling system's for, of course, so that the air at the front of the speaker is not cancelling the air at the back of the speaker as the cone moves backwards and forwards. So this plastic tubing is helping to seal that. The original piece of rubber, I think it was, that they put in there just disintegrated when I started working on this earlier in the year, and so therefore there'd be a big gap in between this masonite and the speaker grill, which wouldn't really allow for very good baffling. So this plastic tubing is a bit of an attempt to help seal it better than it would be without it. It's not going to be perfect, but it's better than nothing at all. So that's why they're there. That's gluing away. So what I'm going to do now, I've got the oscilloscope coupled to the capacitor on the output of the 6V6. So there's a little bit of hum in it, but it's not terribly bad. And I know the capacitors are correct. Oh, something else I've done too, you might remember I mentioned that this isn't the original power transformer for it, so the voltages are different. In the manual, find the manual, there's a table of voltages that were measured with a 1000 ohm per volt meter, and this is back in 1950, so they were probably pretty common then, but they're not very common now. So without getting too much shine on it, there's an alignment table of frequencies there, which is what I'm going through to an extent at the moment. And also, if I can find the right page here, there it is, there's a table of socket voltages for the 528MA taken with a 1000 ohm per volt meter. So these days, of course, it's probably quite unlikely that you're going to be using a 1000 ohm per volt meter. So what I did was I went through and I measured all the voltages with a digital voltmeter, which is 10 meg ohms input, and a 2000 ohm per volt meter, which I've got. And so I've put them in a table so I can use them for future reference if I ever need to do any repairs. I know what the socket voltages should be, and I use the variac, which you can just see over here, to make sure that the input was exactly 240 when I did that. So at least I've got a reference. So we want dial calibration so that we know that this thing is going to try and track with the dial the way it should be. So tracking is normally done at two frequencies, 600 kilohertz and 1.5 megahertz. So because the IF was going straight through it, I had to bring the output of the generator up a bit. However, the sensitivity when you're actually tuning to the frequency of the generator is much greater. So if I bring that up again and we go to 600 kilohertz. Now, something worth noting, this radio dial, maybe I can swing the camera around a bit there so you can see the bottom of the dial, hasn't got an alignment mark for 600 kilohertz here, nor has it got an alignment mark for 1.5 megahertz. So how do you know where the dial pointer should be when you're trying these two frequencies? Well, the answer is the dial has got a lot of radio stations marked on it, and you find the radio stations that were the frequency of 600 kilohertz or 1.5 megahertz, at least at the time when the radio was made. So the one that was on 600 kilohertz is a station in Hobart called 7ZL. 7ZL was on 600 kilohertz. So if we put the dial on 600 kilohertz and we just adjust the generator as well to 600 kilohertz, bring up the output a little bit there, and there. Help if I have it on the right band. Right, 600 kilohertz, and that's got to be 600 kilohertz. Right, as you can see, I've already got it correct, or near correct, because I did a rough alignment on this previously. Now, to adjust that, there's a core for the local oscillator, for the coil, that you adjust, which is this adjustment here. And on this particular radio, that's all the way down for the core to get that to go to 600 kilohertz. I just can't wind it down anymore. So that's just on the limit of the adjustment. We go to the other end of the band then, to 1.5 megahertz, which is a station that is called 3AK, which was in Melbourne, and that was on 1.5 megahertz. So we the generator up there as well. Now I've got this going through a 30 picofarad coupling capacitor, and the capacitive reactance at that end of the band is of course less than at 600 kilohertz. So, and the generator probably goes through it a bit better, so I'll put the generator down to minimum output there. Put this back on 1.5 megahertz. I'm not going to the point of digital accuracy for frequencies at the moment because I'm lining up to what looks right on a dial in the middle of the name of a radio station. And as I said, I've gone through these before and got them roughly right, but just so you see the effect, I'll go for the trimmer capacitor, if I can find the slot. There we go. And I'm looking for the peak again. Some people haven't, well, that's picking up that wonderful fluorescent light again. I might turn that off and try it again. Now, just as by way of illustration, some people might say, why are you looking at a very weak, noisy waveform there, which has got a bit of noise on it rather than a nice clean sine wave, when I could turn up the generator like that and get a very nice steady looking sine wave, as you can just see on the screen there instead. Well, the reason is that the stronger the signal, the more the AGC, the automatic gain control in the receiver, is going to react, and therefore as you tune across the station, the point at which the station is, the frequency of the station, isn't as fine when you've got a stronger signal. And because we're trying to look for alignment and spots of accurate alignment, we need that signal to be as narrow as possible. So, as you see, it can produce a clean waveform, but that's not the object of the exercise at the moment. So we go back down to low output, turn the volume up, and normally when you're doing tracking you have to go back down the 600 kilohertz end of the band and adjust the core on the inductor, and then back up this 1.5 megahertz end of the band where we are at the moment and adjust the trimmer capacitor again, because they're a bit interactive. But as I said, I did this before, and so I know there's not going to be much more change now. But I can show you the other thing you do after you've got your oscillator at the right frequency so that the dial is correct. You normally go and peak the inductor of the RF amplifier at the bottom end of the band, and also the trimmer capacitor of the RF at the top. Now this has not got an RF amplifier in it, it's only got a single tuned circuit coming into the mixer, and that tuned circuit's inductor is not adjustable. So the only thing you can adjust to peak any of the RF end is the trimmer capacitor. So that's under here on this radio, so I'll show the effect of peaking that, and if we had a bit more on the screen it wouldn't hurt. So I'll do that now. Okay. Using the oscilloscope as an output meter is a very sensitive method of showing any changes in amplitude of the waveform as you adjust it. I would say probably even more sensitive than an analog meter, easier to see, and you can see differences that you just can't hear the change. And of course those differences are cumulative, so it makes a large difference when all these adjustments are done. So, what else have I done to it since you've seen it? Oh, I put a new, the second new tone control in it. The original was faulty. I replaced it with 100K, which didn't have the switch pod on the back for the on-off switch. I'll give you a bit of light again. And so I've replaced it with one that's already got an on-off switch on it. so I didn't have to put a separate on-off switch. Also, I've put a 3-core cable power cord on the radio, which means it's now earthed. The chassis is earthed. The original cable was only a 2-core figure 8, it wasn't earthed. So this is a bit better safety wise. Mind you, it's in a Bakelite box and the controls have got plastic knobs on them, so you can't really come in contact with the chassis in normal use anyway. But when you have got test instruments on it, you're earthing it anyway. So I thought I'd give that a go in this case. And the other thing I've done is I've put a fuse in line with that main switch that I just told you about on the tone control. So there's not much more to do to it really. As I say, when I get the X61 converter, if I get an X61 converter, I'll show the alignment a little bit more of that for shortwave and maybe that digital sweep generator. And what I can do, I'll put it back in the box and I'll do one last video showing how the radio stations, because they have shifted in frequency a bit since this radio was made, so the ones that I can pick up easily here still, I'll show you how closely they align with the dial markings and let you hear how it sounds actually using it as a radio, and that'll be it. All the best until then.